What we're looking at is a simple two-element telescope objective, two lenses which were created in the Lens Manager of Apex. Here we see a ray trace through the two lenses, and we can see that collimated light is incident on the system, and it would be converging towards a focus somewhere in this distance. But other things we might do in this system is we have a very long path to the focus here. Maybe I might want to shorten that up a bit, and one way I can do that is to add components such as prisms. So let's unsuppress the ones I've already created, and you'll notice that the light is coming in, and because the prism wasn't there for the ray trace, it's passing through. But what we can do is do a new ray trace and see where the light propagates next. The other important consideration is you'll notice that although I have pre-positioned these prisms, I could also use this ray trace as a way of determining the best position for my prisms. I could simply move the prism back and forth until I make sure I'm properly capturing the light from the telescope on the appropriate face. But instead, what I'm going to do is simply do another ray trace. And now we can see that instead of forming an image downstream from the objective, our light is coming in, and via total internal reflection, it's propagating from this face to this face, then exiting back out of the prism incident on the second prism, where a couple of additional reflections occur before the light comes out and forms an image at this location. And what we've done now is significantly shortened the total length of our optical assembly. But of course, we can go on from there, and the next thing we might want to do is to look at that and say, well, effectively, what we have is 1/2 of a pair of binoculars. So what would happen if we added another set of these components? And obviously, that's what's already been done. So now you see we have two identical systems, and we'll just do one more ray trace. And as you can see, we have the light propagating through both paths of our binocular. And more importantly, we could determine what the distances were between the two focus positions. But we could also then mate this geometry together so that we could take into account the inter-eye spacing necessary, or the range of inter-eye spacings we would need for our binoculars, and then provide the appropriate mechanical design around this optical assembly so that we could create an entire pair of binoculars.